Now, chemical reactivity. In this, what we find is that the reactivity of how the reactivity of the elements changes in the periodic table. What we find is that the S block are very reactive metals in terms of losing electron. So that doesn't mean the P block are not very reactive. They are also very reactive, specifically which are lying as on the right hand side as possible. They are reactive in the different sense that they are reactive in terms of accepting electrons, because they have a tendency to accept electron. They have a non-metallic character. So if the reactivity cannot be as such defined on one parameter, what we find is it's very important to study the nature of the oxides in terms of the chemical reactivity. And the nature of oxides always is studied period wise, because that is how what we find is that the chemical reactivity changes, the nature of the elements changes, and the nature of the compound changes. Let us take the example of the third period elements that they form sodium oxide. Then we can have magnesium oxide, then we can have aluminium oxide, then we can have silicon dioxide, then we can have phosphorus pentaoxide, then we can have sulfur trioxide, or we can take like dioxide, and then we can take dinitrogen heptaoxide or chlorine Cl2O7. So now what we find is these are the oxides which we get along the period in the third period elements. Now these two oxides are basic in nature. This one is amphoteric, this one is weakly acidic, and these three are actually acidic in nature. So what we find is as we move across the period, the nature of the oxide changes. It changes from basic to acidic. The reason is because the size of the major central atoms decreases, their electron negativities increases. As per the Fazan's rule, we know as the size decreases, the nature of the oxides or the compounds increases. It becomes more and more acidic, and that's why what we find is the acidic character is increasing along the period, and the basic character is decreasing, and the in between or middle series oxides are actually amphoteric in nature, which means they show properties of both the acidic and basic.